Good evening.
Good evening.
Is it clear, my voice? Can you hear me clearly? Yeah, okay. Thank you, Kelvin. Okay, so before we begin, so just reminder, yeah, tomorrow morning. So perhaps if you want to do some last minute, reading tonight, maybe, but not too late, yeah. Okay, tomorrow you have to be up and early, very very early in the morning, correct? Your what do you call this advanced complaint at work um exam is in the morning session, right? So you want to have plenty of rest lah, yeah. So today I just want to just give you first of all some feedback on your coursework, especially the midterm test, yeah. Just some feedback, and then after that we'll pick apart one past question paper, okay, so that at least you won't be too surprised tomorrow, okay, right? So I hope you've been doing some reading on the NetAcad and also did your um, online exams, right, or your NetAcad. In fact, you can use it actually for revision, yeah, because a lot of materials are online, okay, more than what you have in your slides, okay. And I believe I said it for a week since my announcement earlier on in the Google Classroom. So you guys still have time lah, right? If you don't have to rush, if you haven't done it, right? Okay, so let's proceed first with the MTT. So let me just. I will focus more on those questions that you miss out. Both of you got very good marks actually for MTT. By the way, did you guys manage to get back your paper?
Yeah.
Yeah, you got it, Kelvin? MTT, yeah, okay, good. I did make a mistake. I actually uploaded your files into the folder in CN and the CN guys into ACN, but since the rights, don't worry, the rights are individually given. So apart from yourself, no one else could see your paper lah. So if you worry about that, don't worry. Yeah, the rights are I actually individually set it, even though the folder is, Okay, so let me just share. All right, so I'll basically focus on what you got wrong instead of what you got right now. Okay, so it could be very fast like this one. Right, so let's start with question 1. Can you guys see question 1 on the screen?
Right.
Yeah, you can see, yeah. All right. So if you guys have your question paper beside you, your result, answer paper, that marked one beside you, that will be easier for you to follow that. All right. So let me just arrange my window first. Okay. Okay, so this one goes here. Paper goes here. This one comes here. Okay. Right. Okay, so for question 1, Um, the 16 marks there. Of course, in the exam, probably not that much, yeah, for that particular question. But for the test, question 1A was 16 marks. Both of you managed to do it. That means you got all correct for it. Yeah. Okay. So we move on to B. So B part I. All right. So B part I, basically, you need to get 6 marks, right? So if you don't get 6 marks, meaning you forgot something, right? So what you forgot is the IP. You have to put in whenever you put PVC version 6 route. By default, the IP version 6 unicast routing, right, is not enabled. So you have to enable it. You have to enable it by typing IP version 6 unicast routing. Okay. All right. So next, so B2 got 5 marks there, right? B2, what you need to have answered there is that you need to put in IP version 6 route. You need to put in IP version 6 unicast routing, and then it means the after IP version 6 route, you have to put in the address, right? Okay, so you need to put in. Don't forget to put in the prefix and the prefix length. Okay, and then the next hop IP address. So basically, if you miss out any, okay, that means if you miss out IP version 6 unicast routing, you lose mark there. If you lose out the command IP version 6 route, that means you miss out the rest. So that's a lot of marks lost. Okay, in this MPT. So the counting of marks is how you construct it. So you must be complete. IP version 6 route, the address, don't forget the prefix and the prefix length, and then the next hop IP address. Okay, has to be complete. Okay, if you don't get complete, means you're missing some of the answer there. All right. Okay, so the next one is basically you want to provide another ISP2 router to connect, right? So both of you actually got this, yeah, and the marking for this is in terms um, of that. So that means the marks is given when you have that router ISP2. Okay, then you provide the interface. Okay, interfaces on router BB and ISP2, right? When you give the um, what else here? I see here the address. Okay, the address at each interfaces, right? So I think it should be provided the info. You can see here from C part I, right? Label the routers port numbers. That means interface here, and then IP6 addresses assigned. So if you miss out any, then you can lose marks. Okay, that's for C1. And then for C2, propose IP version 6 floating default route and IP version 6 standard static route in the respective routers using the next hop IP version 6 address between ISP2 and router BB. Justify the purpose. Okay, so first of all, you have to propose and then justify what is the purpose for floating default route, and then specify the router name when you are providing the configuration. It's quite big. This one, 17 marks, right? So I think Sharp, you miss out a lot of marks here, yeah, right? Okay, so Noel got more marks, but still not able to get the full maximum 17 marks. Right, so the marking here, all right, so justification here, if you provide justification, you get 4 marks, right? If you provide the router configuration, so each of the router that you provide configuration, you get marks, ISP2, router BB, just indicating that, okay, this one is for router BB, this one for ISP2, you already got 1 mark each, right? And then the construction of the IP version 6 route, okay? For ISP2, the full construction IP version 6 route means the full command is 4 marks, and the full command for the one in router BB is 6 marks, right? So basically for ISP2, it's IP version 6 route 2001 ABCD AABB 1, okay, then colon, and don't forget the prefix /64, and then the next hop IP is 2001 ABCD AABB 42, okay, 42, and that means network to this IP, right? Router BB, IP version 6 route, and the colon, right? This one is on the router B, okay? The ISP2 router do not need this one on the router B. So basically, that is a generalization, right? That means any network, right? Colon/0 means any network to this interface 2001 ABCD AABB 4 :1, and the 55, you can put 55, you can put as long as the AD that you provide after that administrative distance is bigger than 1, then you get the marks. All right, okay.
Okay.
Okay, right, so okay, so we move on to question number 2. Only 2 questions. Question number 2, reconnaissance attack, right? They can ask you other attack. This is just one type. So what is reconnaissance attack, and one technique to conduct that attack? That means from the point of view of the attacker, right? So you guys are okay with this, I see, right? No problem at all. So we move to B. Okay. Now the only difference, during the MTT is open book, right? So I'm afraid if you are going for the exam tomorrow, it will not be open book. So you have to if this kind of question comes out, also you have to memorize it, right? So I'm not sure which attack, if there's any question on attack, will come out, right? Sorry. Question, need to draw a lot. This one. I won't say there's no need at all, but I'm pretty sure the examiner is very aware of the fact that it will be all handwritten. So if there is a kind of drawing, I think it will be minimal rather than a lot. But I won't say that there's none. Okay, I don't dare to say that there's no drawing red diagram. But I would think there will not be too many, because it is physical, right? So you don't have the tools to draw. So remember when you're doing hand drawing, yeah, because it's physical, right? The important thing is to label your diagrams. Okay, if there is any question asking you to draw diagrams, all right, then because well, it's not expected that our may be acceptable, but may not very accurate our drawings, right? Our diagrams drawings, as long as uh, it sort of look like, let's say, router looks like a router, PC look like PC lah. But just in case, the most important thing is you have to provide the labels lah, just so that the examiner will be able to recognize what is that you draw, right? Okay, so hope that clarifies a bit, yeah. So okay, so after A we go to B. Okay, for B, we see that there's a network topology there. North and south routers. You can see north on the left and south, slightly to the right. Yeah, down a bit. Okay, connecting various sub networks. Okay, so here the question is about OSPF. All right, so let me just see. There should be about 16 marks. All right, so well done to Shakla. Noel, you missed out. Let me describe how the marking is there. So at least you know question 2bi. Yeah? Where is it that you make mistake? So the immediately when you put in the router name, okay, north and south, each of those you indicate, then there is a 1 mark, right? And then for north, then you provide the OSPF configuration, right? So both north and south, you must put router, and then the command router, OSPF, and the provided process ID, which is 3181, right? So as when you put in for north, you put in for south, then you get 1 mark each. So again, you get 2 marks there. Now, this OSPF configuration, I think for Noel, you macam you put balik, right? Okay, terbalik, the IP address is terbalik. Okay, so let's see. For North OSPF configuration is you should put network 172.16.100.0 with its wildcard mask 000.255 area 0. Okay, and then the next one is network 172.16.103.0.000.255 area 0. And the third, network 192.168.80 wildcard 0003 area 0. That's for north. For south, you got network 192.168.8.0 wildcard 0003 area 0. And then network 172.16.200.0 wildcard 000255 area 0. And then network 172.16.206.0 wildcard 000255 area 0. Okay, so basically, Noel, you terbalik it lah. As you can see, yours is 172.16 is in north, right? And then once you get that one, that means the other one also wrong lah, right? So that's why you lose marks. You lose marks there. Okay,
Okay.
all right. Okay, so Kelvin, for that is okay. All right, so let's move to question 2b2. 2b2, analyze figure 2 and write an access list numbered 772 to allow laptop 3 to telnet into the south router. So basically, laptop 3 is here, right? This one is laptop 3 on your right hand side, okay? And we want to allow laptop 3 to telnet into south router, right? So deny all other traffic to south, okay, except for laptop 3 telnet. Use keyword in your ACL, indicate the router interface and direction to apply the ACL. So basically, you will encounter ACL definitely, just like OSPF, you will encounter during your exam tomorrow. So make sure, okay, you go through. If you want to do this, you go back to your what you did in your workbook. All right. So a bit of practice there. All right. So uh, actually, you guys did very well here, lah, right? So the only mistake that Noel did is the line VTY 015, right? It's actually 04. Okay.
Why until 4?
I think I believe that's by default you just provide 0 to 4.
Oh, okay.
Okay. Okay. That's just one mark that you lost there, lah. Okay. And then B3 is a bit a little bit harder, lah, I guess, yeah. So because both of you lost marks there quite a lot, okay, because it's 18 marks altogether. So you can see that it says you write an extended access list called restrict access, right? So that one you both of you got it correct. Restrict access, but I'm not sure why is it that for Shark, yeah, Kelvin, you put access list name media center. Is there any media center here mentioned?
Oh, no. I copy paste. I forgot to change the media thing. I copy paste from the homework, the tutorial. Then I
Oh,
forgot to change the name.
oh, you forgot to change lah, right?
Yeah.
Yeah. So that's why I was wondering why there is a media center. So that's okay. All right. So if you're still depending on what open book be careful because this is no it's a closed book lah, right? So you have to know how to configure this ACL. Okay, so I think you can see where the mistake is for your configuration, right? But the first one, of course, you guys got it right. IP access list extended restrict access. You get marks there, and it's supposed to be permit TCP host 172.16.103.10 host 172.16.200.254 equal 443. 443 basically represents HTTPS. It's a port number for the secure HTTP 443, right? So you basically permit that only, right? And then the second part is permit ICMP host 172.16.103.65, right, to 172.16.200.0 wildcard 00063. Right? Then the next one after that, ICMP, you guys know, right? It's ping, right? The protocol for ping is ICMP. Okay, and then there's no port lah for that one. So the third permit is permit ICMP host 172.16.100.200 to 172.16.200.128.000.127, which is the that's the wildcard lah. Okay, and then deny IP any, right? Okay, so for north, okay, for north, you need to put in at interface. The moment you put north there to indicate that that's north router, and then it's one mark there already. Interface for interface S021. Okay, you indicate that because you want to go into that interface to configure, right? You put IP access group restrict access out, right? Okay,
This one got marks are the one the interface S021.
sorry.
Is there any marks in applying the ACL?
This IP access group restrict access out.
Yes.
Let me see. Yes, there's a mark there.
Oh, because mine not, there's no tick.
All right. So, did I miss any marks, Noel?
I think got
Miss this one, right? IP access group restrict access out. Yeah.
yeah.
Okay. Noted. And noted about that. Sorry about that. Yeah. It's 2 marks there, so about 1 mark lah. 1 point something mark after scaling. Okay. Okay, so that ends the MTT, right? So your the other is SBA, right? So for your marks, yeah, actually your MTT is quite good, the marking, right? The marks that you get, but the final marks, okay, due to the SBA for Kelvin, right? So the marks a bit lower, Kelvin.
Or is it fail?
Oh, not fail. If fail, I already asked you to do make good, but it's just hovering above 50 because your marks for SBA is quite low. It's below 50, right? So, but fortunately, your MTT is high, so it brought up your marks lah. It brought up your marks to pass, right? But you have to be careful when you're doing your exam. Yeah, Kelvin?
Okay. Is the
Yeah.
exam also more drawing and the code or
Okay,
speed?
so yeah, I will talk about the how the exam is going to be. All right. So just that after this we'll talk about the exam. Right. So now just the coursework. So Noel is okay. Noel just keep maintain your marks. Right. Noel.
Okay.
Right. For Kelvin, because I see your MTT is actually not a problem compared to SBA. So the exam should be also, I expect, okay lah, right, Kelvin? So if you just keep on doing what you're doing with your exam tests, exam paper, then you should have no problem lah. All right. But I have to say that your grades for your coursework is ngam lah. C, C. Okay, so you have to be careful.
Okay.
Okay. All right. So let's talk about the exam now. So I'm gonna talk about. Hang on, let me just get my question paper. So if you guys go to the repository, you notice that there are not many papers, yeah? You
It's
notice
both.
a lot?
It's
If
both.
you go to repository, there's not many paper. So what I actually shared with you is the paper that I also got from repository. So the reason being that the older paper, I think, is removed because as you know, CCNA syllabus is is the syllabus that we follow, right? So time to time, Cisco will update their syllabus. What that means is that certain topics is dropped or become smaller, certain topics added, and also more focused, right? So if I believe they remove those papers just in case students basically it's different code also last time. For last time, if you still want to see, I believe the old code is BAIT, not BMIT. Okay, so the old code is You want to see those before the pandemic? It's BAIT 3094 rather than BMIT 3094. All right. So there might be similarities, but there may also be some topics that may not be focused on in the the current syllabus. All right. So what I'm going to discuss with you today is the April May 2020 2021, right? The paper. Now, based on a question just now from Kelvin, a lot of, if you notice, actually the question is for me personally, it's not going to be much different. Okay, they may minimize the drawing of the diagram, but in terms of the type of question, right, that they're going to ask is should be similar, because not only this is a high level question already, this is bachelor question, so there are not many those theory type question. All right, so a lot of it is going to be application, high level blooms lah. Okay, so expect similar questions to come out, right? But what I can say is that the typical topics that we have already covered, right? So like routing here, routing table, as you can see, OSPF, right? Designated router, this one BDR, DR, all this will come out. OSPF will come out. Okay, and I believe SCL definitely will come out. Okay, here is ACE, but SCL and SCA together. Right, so here there is a DHCP. This one didn't come out in MTT because we haven't reached that topic yet. But you know, this one might come out, right? The subsequent topic, right? NAT definitely I think will feature somewhere, right? And IPsec, the thing I'm not too sure. If I look at the question, if I look at another question, which is December, I think it's December, is it? Okay, let me see in our what I shared with you, the October, sorry, October, right? So coverage for October, right? So here I can see that it's routing as well. Okay, static routes and maybe floating routes. Okay, OSPF also came out, and the network security. This one is social engineering, right? Network security comes out. Access control list comes out. So DHCP comes out, right? And NAT, PAT comes out, and a bit of question 4 is a bit what error network and a little bit of critical thinking kind of questions lah. Right? So you can see there's virtual private network. These are towards the later part of our lectures. Yeah. So the one that I'm not too sure, right? Because I've never seen it come out yet, because I think that's the new part. The new part, if you guys notice, the network automation, network virtualization, network design, network troubleshooting, right? Okay, so these are the part that I'm not too sure how the question, if it comes up, right? How the question is. These are the new part of ACN. Okay, so it could be just comes out. There's a lot of theory in there, right? Rather than real application. Okay, so if it comes out, it might ask you in terms of theory questions, right? For that part. Okay, but those I mentioned earlier, those definitely will come out because that's traditional. It's going to come out. All right, so let me start going through here, right? Right, so the first question, you're asked to look at figure 1.1. Okay, you have to, these are information that might be useful for you to have a look at while answering. So each of the question A1, for example, is to identify and explain the type of static route. So basically, when you look at this, your answer, okay, you identify it. So basically, this is a default static route. Okay, identify, you get marks, and explain, you get marks. So there are 3 marks here, right? So 1 mark should be for identify, 2 marks for explain, right? So basically that is a default static route, and then you explain what is that default static route, right? And then here you're given this, identify again, explain, same way, the marks going to be assigned. So this one is what is this? L209 is directly connected via that interface, right? So this is called a host route, also known as local host route. Okay, and then explain what is a host route. Basically, it's an IP address, IP version 4 address with 32-bit mask, or an IP version 6 address with a 128-bit mask. Okay, so why do we have host route? Because it allows for a more efficient process for packets which are directed to the router itself rather than for packet forwarding, right? So that means instead of it's to be forwarded, it's meant for the router itself, right? So that's a host route. Then the next one, okay, number 3. what is this? To identify this, so this one again, identify is 1 mark. That means explanation will be 3 marks. So that means there are more things here that you have to mention. So this is basically a floating static route. Okay. So you identify it, then you describe what is a floating static route, what is used for, right? So basically that is a backup path to the primary static or dynamic route. Floating static route is only used when primary route is not available. So it's a kind of redundant system lah. If your primary route is not available, then floating static route will take over, right? So and that's the bulk of the 2 marks. 1 marks again is given for floating static route is configured with a higher administrative distance than the primary route. So higher, it must be higher from the primary route. So lower administrative distance is better. Okay, you have to explain that. So primary route with lower administrative distance will always be selected. Okay, compared to the higher administrative distance for floating static route. So because floating static route is basically a backup path. Okay, so it should have higher compared to primary route. Right, so question 1B. Assume all the physical interfaces are active and routers have reached a convergence state. Right, so this is our SPF network. So we assume this is going to be OSPF here. Question here. All right, so this type of network, what is it called? This is you can see here the switch in the middle. From the switch we go to 3 separate routers, right? So any host connected to this switch will be able to go to different routers. So this is what kind of network is this? This is called multi-access network. Okay. Right.
Okay.
So yes. Any question? Any comment just now?
No question.
Oh, okay. Right. So that's part 1. This is a multi-access route here. And question part 2 is asking what is the router ID for router 1, 2, and 3? Identify the router ID. So here you have to know which one. Which there are several ways you can configure router ID, right? There's a default one, okay, and then after that you can also set it manually, isn't it? Yeah. So the first thing is if the router has a loopback interface. Notice loopback interface, LO1, LO2, LO3 here. Notice, yeah? So if you have the loopback interface configured for the router, the address, okay, the IP address that's provided for that loopback interface, right, will be automatically taken by the router as its router ID. So all 3 has, right? So simply pick it up. Router 1's router ID is the IP address for its loopback interface. So 77.128.3.5. Without this one, without the prefix /30, don't write that. And then router 2 is 192.168.2.1. And router 3 is 192.168.3.233. Okay? Right, huh? Okay. So, and that's it. Then part 3, it says identify the designated router backup designated router, BDR, and the DR others. Justify your answer. So basically, you need to know the election process that goes on, okay, where which router become designated router, which router become backup designated router, and then then the rest are DR others. Okay, so how do you find out which the election process?
The interface priority.
Yes, interface priority. So you compare their interface priority, right? So is it the lowest or highest?
Highest.
Highest, right? So highest, immediately we can see router 2. Okay, router 2 has the highest interface priority, which is 100. So router 2 is the designated router, the DR. So you have to, when you answer, you have to say router 2 is the designated router, or router 2 is the DR. And you have to explain why. Okay, not simply to identify router 2. That's it. Then you have to say, oh, router 2 is the DR because it has the highest interface priority, which is 100, compared to router 1 and router 3. Full answer. Identify and explain. All right. And then, how do we know which one is the BDR, the backup DR? So priority is the same, right? In terms of the election process, what happens if priority is the same?
Use the router ID.
Yes, router ID. Okay. So if priority is the same, then we have to look at router ID. Okay. So which one's the winner? The highest router ID or the lowest?
Highest.
Highest, right? Correct. So router 3 is the winner. Router 3 is the BDR, or backup designated router, because even though this is the, after you answer that, right, you have to explain, right? Even though because the priority is the same, then we have to look at the router ID. So the router with the higher, or the highest, right, router ID will be elected. So this one start with 77, this one start with 192. 192 definitely higher than 77, so router 3 wins. Right? Next, we have to identify DR others. So router 2 is already DR, router 3 is BDR, then the remaining router you identify. Router 1 is the DR others, right? Because once the DR and BDR is identified, all other routers become DR other. Okay, DR other. Okay, got it, huh? Okay, now let's move to number 4. Okay, number 4, identify the class D address used by the designated router to send update packets to all routers in the same area. All right, so class D. What is class D? We have class, this is taken from the, if you recall your FCN, you have class A, B, C, D, right? Still remember? So class D is basically used for the sharing of router information, right? So it's a multicast IP version 4 address, specifically IP address 224.0.0.5, right? So the DR uses the multicast IP version 4 address 224.0.0.5, which is meant for all OSPF routers. Okay? Right. So that's class D. Class D, yeah. Okay, so next is part 5. Part 5, router 1 has been configured with the default static route that uses interface loopback 1 as the exit interface. Write the command to propagate default route into the OSPF. Right? So process ID 33, OSPF network, process ID 33. I remember this. Okay, so you go to router 1 in the config, type the command router OSPF 33 because you want to configure for OSPF, right? So our OSPF process ID is 33. So router OSPF 33 followed by this one to propagate. Okay, the default route, the command is default information, that means default dash information originate. Okay, and that's it. Two commands in router 1. First, you need to configure that originate thing, yeah, inside the routers or SPF. So to identify that this routers participate in the OSPF network with the process ID 33, right? All of them are process ID 33. So router OSPF 33. The next command, when you inside the config router, type default dash information, then originate. Okay, right. Next, propose the open shortest path first OSPF configuration in router 3. Okay, 2 marks. Router 3 only, yeah. So there are multiple ways you can do this. In fact, there are 3 identified ways to do this. Okay, but we are asked to do only for router 3 lah. Huh? So router 3. Okay, you have to go into config router, right? So again, same as just now, router OSPF 33. Okay, so for router 3, okay, you want the network. Which network? Hang on, which network that is?
Is it the loopback 3?
Sorry, Noel?
Is it the network is the 192.168.3.233?
Yeah, we need to actually do this 192. Yeah, this one. But hang on now. Yeah, yes, 192.168.333. Okay, 2333 there, and then 000 area 0, and then another one will be 172.16.2.19, again 000 area 0. I'm trying to figure out the other type of configuration. Okay, the one that you mentioned, Noel, is correct. I will go for that as well. 192.168 network, the 2 network command. Okay, 192.168.3.233, then 0000 area 0, and the second network will be network 172.16.2.19. Again, wildcard 0000 area 0 as well. So that's one possible answer. For that, you get full mark already. There are a couple of configuration also here. One using the interface G000, and then you can just simply put IP OSPF 33 area 0. Okay, that means the configuration is based on the interface itself. So the second command for interface is interface for this one, loopback 3, and then IP OSPF 33 area 0 as well. So basically, we just want to say that these two separate network connected by router 3 belongs to the same OSPF process 33 and area 0. Right? So I'm pretty sure the first method is basically giving the interface address, right? But I'm not quite sure. So I will leave the other. I think I stopped with the two alternate answer lah. One using just now the address, and then the other one using the interface. Does that make sense to you guys, Noel and Kelvin?
Yeah.
Yeah, Kelvin. Any comment from you, Kelvin?
Or use the wildcard subnet, right?
Sorry, Kelvin, I can't hear.
Use
Yeah, wildcard. So basically, the first one is like this: router OSPF 33, and then followed by network 172.16.2.19 and 0000 area 0. Okay, then the second network will be the other network, which is 192.168.3. Again 0000 area 0 as well. So that's one way to configure it, and you get full mark already. But
no, I
just,
mean,
sorry,
not 0000. Oh, is that? Oh, is it? You asked? Oh, is it the number 5 default?
yeah, it's a wildcard lah. That means yeah. So the other type is interface. You use interface instead. So G was like that, right? Going for that interface, and then you say that for using the interface method, you don't have to put router OSPF 33. You basically put it in the command IP OSPF 33 area 0, straight like that. Okay. So two interface G000, and then IP OSPF 33 area 0, and the same with the loopback, because the loopback is the other interface. So you say loopback 3, right? You identify it, and then type the same command of IP OSPF 33 area 0. So if you do this way, also in chat message there, also acceptable, right? Okay, so let's move on. So this finish question 1, and we go to question 2. Compare IP.
I mean,
yeah.
the subnet is it? Should it be 0000 or should it be 00 128 or something like that?
No, it's 0000.
Or the what? I thought we used the wild mask one. Not that.
So that means everything match, right?
Everything. Oh, okay.
Yeah, everything match, right? So that means whatever addresses will match lah. Okay, we don't filter. If you put the mask with the mask there a value, then it will filter. So certain address will be filtered lah. Yeah? Okay. Only matching will be what lah configured. Those not matching, since we want all the addresses, so we just put all match lah. So, but remember, wildcard is actually a filter. All right. Okay, no problem. Right. So, question 2A: compare IP vulnerabilities to TCP vulnerabilities. So, this one, unfortunately, you need to know lah, right? What are the vulnerability when it comes to security in terms of IP and also TCP? So, the thing is, IP is a different layer compared to TCP. TCP is transport layer. IP is network layer. So at network layer, what kind of attack is available, and then at the transport layer, what kind of attack is available. So you just basically provide side by side lah, right? So basically for IP, right? You get to get attacks like ICMP attacks, address spoofing attacks, man-in-the-middle attack, session hijacking, amplification and reflection attacks. This you have to see the attacks are actually tailored to what services or functionality that layer provide. So we know IP is at the network layer, so the kind of services at uh, the network layer is the one that is going to be attacked. Same with TCP. So TCP, you know that the TCP before TCP is connection oriented, so it will create session, right? So whenever it creates session, it sends the three-way handshake, the sync, acknowledge those TCP handshake, right? To start the session. So that is being attacked. That is one of the attack that's going to be done by the attacker. So we call it TCP sync or synchronized flood attack, right? So what happens in that is the threat actor sends multiple sync requests to the web server, for example. The web server replies with, of course, sync acknowledge for each sync request and waits to complete the three-way handshake. But the threat actor does not respond, right? So you do it many times, and you basically exhaust all the TCP connection. Of course, you don't type. I mean, you use a software, right? Software can send, and if you have many zombie machines, sending this SIM flood attack, the flooding, basically you flood it. So imagine whenever the web server receives a request, it opens a thread. In terms of programming, I'm just explaining more than you should. You don't have to explain so much, but I explain to you. Whenever a web server receive a request, it will serve the request by opening a thread. A thread is, a thread of execution within the web server program, right? So basically, if an attacker is flooding it with sync requests, but it's never acknowledging the open thread, the open sync, yeah, will remain open. Okay, and then if you flood it, that means, let's say you send 1,000 open without any closure, right? So what happens is a denial of service, right? A valid user will not be able to access the web server because it will have too many half open TCP connection, and it will run out of threads. Basically, it will use up its internal memory, okay, the server. So this is called a TCP SYN flood attack. Okay. So so we can also talk about the IP vulnerabilities is that IP is insecure. It does not validate, right, that the IP address that is actually that's inside the packet it received actually come from that IP. IP actually come from the IP address. That means if someone changed the IP address, whether from man or middle attack or from the actual source, okay, then there's no way for any of the devices, whether end device or intermediate device, to check. There's no feature for that for checking, right? So that means spoof source IP address can easily be done, right? That's one of the IP vulnerabilities. Okay, so okay, so for IP vulnerabilities also, threat actors can use ICMP for reconnaissance and scanning attack, right? They can launch information gathering attacks to map out network topology discover which hosts are active, reachable. Well, basically, you do it yourself for troubleshooting. You ping hosts, right? So if I write a program, I can just ping a range of address. Any of the address reply, I know that address is a end device that's online. It's an end device or intermediate device, can be switch or solar, right? So it's basically pinging, right? All the addresses, automatic. You write the software yourself, then it replies to you. So I can easily figure out how many hosts is available, is online. It's such a threat that some services basically they disable ping. But you disable ping, then yeah. So basically, disable ping means you block ping requests lah, right, through your router, right? So you in your ACL, that means you only allow ping from certain terminals or workstation that you know is can be used for troubleshooting, right? Okay, so for the for TCP, continuing from the TCP sync, that one is for connecting. Terminating a session, you know that's always also there's a handshaking going on to terminate TCP session, right? They have to agree to terminate basically. Once they're connected, they must agree to terminate, and this involves handshaking as well. So when the client no longer wants to maintain the connection, it will send a FIN flag, right? Then the server sends acknowledge, okay, to that receive the FIN to terminate the session. Then the server also will send a FIN with expecting the client to send acknowledge also lah, right? So of course in the in the valid one, the client respond with an ACK to acknowledge the FIN, and then both terminate connection, right? But a threat actor could do something called TCP reset attack. What the threat actor does is to send a spoof packet containing a TCP reset to one or both endpoints, right? So that means never can terminate, reset. Every time you terminate, reset, right? Reset. Because again, this threat actor can always send the spoof packet. Actually, it's related to that. Because the TCP doesn't check IP. You see, so the network layer, if it's already spoofed with the IP address, then TCP doesn't check anymore. It's always trusting the network layer. So the threat actor could be representing the IP address of the one terminating and keep sending reset, and it can be sending reset to both party. All right, so threat actors can do this one for IP. Can use amplification reflection technique to create denial of service attack. The example provided here is Smurf attack used to overwhelm a target host. Right. So basically, it is a denial of service attack. The examples are amplification reflection technique. I'm not sure this one is this mentioned in more detail inside our NetAcad? I don't remember reading amplification reflection, right? So maybe you don't have to go into too much detail. Simply talking about denial of service attack is okay already. And you give example on denial of service attack. For the TCP session hijacking is one of the TCP vulnerability. This is quite difficult to achieve lah, right? Because what happened is, let's say the TCP handshaking already conducted, so the two hosts connected, and then a threat actor will try to take over, right? To take over either one of the hosts lah. Okay, pretend to be. So what the threat actor will do is it looks at if you can capture the because the way they talk to each other is by sequence number, right? So what happens if we can intercept and get the next sequence number, it can predict it, then it can send and acknowledge to the other host. If then it's successful, the track actor could send but not receive data from the target device. So it can manipulate it that way, TCP session hijacking. Right? So IP address spoofing is basically for IP address for network layer vulnerability, basically providing false source IP address to hide identity of the sender or to pose as a legitimate user. Right? So it's actually a part and parcel of the other attack, right? To hide identity. And when you attack, you basically when they try to trace back, they cannot trace you, right? So although we describe different attack, a lot of times the threat actor will use multiple in one session, right? Multiple different types of targeting different types of vulnerability within a single attack, right? All right, so you see at marks there. So you just need to provide 2 points each. So for IP and TCP, right? Then 2 points, 2 points, 2 times 2, 4 points for IP, 4 points for TCP. 2 points times 2 marks, so, right? But in order to get 2 marks per point, you have to provide explanation. Okay. All right, going to B. We are given a network topology here with a standard number access list to block 17250. So let's just space it 101 to block PC1, all right? 1725025.101/24 PC1, right? And 172.50.25.102 is laptop 0. We want to prevent, or we want to block PC1 laptop 0 from sending information to the 212.77.70 network. So this network, right? So so you need to create the access list, right? Okay, so you can give any number. I don't think it's provide here, right? Yeah, there's no access list number provided, so you just put in any you want. Okay, so access list, let's say I take 55. So access list 55, deny 172.50.25.101, right? Or access list 55 deny host 172.50.25.101, or access list 55 deny 172.50.25.101 with the filter of everything 0000. Okay, and you want to put we want to place that access list at the where, RB or RC?
RC.
As close to the destination as possible, right? So at RC, yep, at RC, correct router will be RC. Yes, Noel?
In the chat box.
Or do I have to write the router config thing at the front?
Yes. Especially, it's only worth to write that if you put the router name there before the config to indicate the name of the router. So
exactly.
let's say instead of putting router config, you put RC config. Then that serves as an indicator already.
Oh, so you have to write that for every line.
Yes.
Okay.
Yes, you can, and you can write,
Can
and it's good also.
cannot
Router
write that
config,
because
but the router, make sure the router there you put is the correct router name lah. So RC config, something like that. Then it's understood. Oh, you're putting this in the RC, for example.
no, I mean if I don't write I just directly write the
But you
command,
have, yes, if you
but I don't write
directly write, yeah, you directly write the command, you have to explicitly say, okay, this is
if I
for,
got on top I got the title there, router name
and then
is
underline it. Yeah,
router name equals or something. Router name is RB or RA, and the
yeah,
interface
can,
process.
yeah,
And then I can
can
skip
also,
writing the router at the front.
yeah, can
Yeah, because save time.
save time, right?
Yeah.
Can, no worries. But yeah, just you have to be very clear. Those commands are for which router. Okay.
Okay.
All right. So there are three ways of writing. Just now, either you put in immediately the IP address of the PC, access list, then the access list number. Access list, I use 55. Deny the IP address for PC1, or IP address before the IP address you put host, or instead of host, you put IP address, but you follow by the wildcard. Okay, and the wildcard should, because all right, all traffic, so 0000. Okay. Similarly, the next one will be uh, very similar. You have three options, but for the laptop address. Then after you put the ACL for the laptop address, then you put in access list 55 permit any, right?
Okay.
Because because you're indicating that apart from these two IP address, the rest can be forwarded, right? Then where you want to put it, interface G001 IP access group 55 out. Okay, that means means out from the RC, but going it should be, if you look at it from the point of view of the S2 network, means it's coming in, right? But because we are putting on G001, so means the egress interface there is out. Okay, IP access group 55 out. Okay, so that's it for part one. Part two, write a standard name access list. So here we want to use the access names are given already here. Permit upper. Okay, as long as you got name, the question should provide you the name. Right, write a standard access name access list to permit traffic from the upper half. Upper half normally 1 to 7. Sorry, 1 to 8. 1 to 8. So the wildcard always half of it, 0.000.127, right? Upper half, right? And then you permit that automatically. If you deny, then it will be denied the lower half, but you already permit the upper half, so upper half still can flow through. All right. So this is the always remember when you put in the access ACE, it always follow the by the order that you enter the access. Okay, right? So if you want to permit permit first and then deny. Okay, and once you deny, it will only deny the other range that is not permitted. Okay. Okay, so in fact the question here very nice. It gives you step by step, so you just follow it step by step. It's okay already. Right, so you start by identifying the router. Where is the router? So this one from 212, from the right hand side to 172. So it should be, the rule is destination, right? Destination router. Okay, the traffic from 212 to 172 network. So which router should I configure this? Router B. Right? So at router B, you identify router B. And then you create IP access list standard, and then the name, permit upper. Okay. And then permit, let me see, 212772. Yeah, this one, but allow only host, because later you want to deny, you want to allow this one go on top, right? You want this to go on top. Okay, so permit host 2127772. That's it. Okay, so the first rule is permit host 2127772. Okay, and the second rule, you want to do this one. We want to permit the upper half. So permit 21277.7.128 with the wildcard of 000.127. Right? Then to block the lower half, we just put deny 2127770 network. So 0000255. It will not block the permitted already above. It will only block the remaining address. Okay, and then permit any. Okay, then once you have already set all the permission, then identify the interface that you want to put the .acl. Also interface G000 still on router B. Then IP access group, instead of using the number, we use the name, right? Permit upper out. Any question?
No.
The rule is allow first, then deny, then permit. If there is a permit any, then permit any. If there's a deny all, then deny any, or deny any. Make it explicit lah, the deny part. Although we know there's a deny at the bottom, but make it explicit. Right? Rule is start with the permit first, and then followed by any deny, and then that's it. Right? If no comment on that, we'll move to part 3. Right? Write an extended number access list by using keyword to permit keyword. That means we're going to use like TCP and for example and then the port keyword if available right? So HTTP, what is the traffic is www, right? And it's actually TCP transport is TCP because HTTP traffic must be reliable, right? And then and that's it. I think that's it. HTTP is www, right? And it's TCP. So we're going to use extended number access list. Is it given here? No, so we can provide our own. Okay. Right. So you start with of course you identify the router. It says here permit traffic from 212 Where is 212? 212 network to web server. 172 web server is here. Okay, permit HTTP traffic from here, this network, to there, but deny first 15 usable addresses. So that one we handle by using the the card to web server, intended for web server. This one permit HTTP traffic to any other web servers. Apply the access control entries to the router interface. So okay, first we have to identify the router. Okay, which router should we block? This one is for blocking HTTP traffic, to allow HTTP traffic from this network to the web server, but deny the first 15 usable addresses HTTP traffic in here. So that means allow only the 15 usable, the rest are blocked. Sorry, deny the first 15 and the rest are allowed, isn't it?
Okay.
All right. So which router should we select? R, A, B, or C?
RC.
How about you, Kelvin?
RC.
RC, correct? Huh? RC. Right. So RC, we want to not even, because we're filtering based on the content. We're not even going to allow it to enter to be forwarded, right, in the RC. So this is the interface that we're going to put the S in, G001 in. Okay. Right. So I'm gonna pick 185 as my number. Okay. Access list 185 deny TCP from this one, right? But only the first 15. So 000.15. Okay, to this particular computer. So host 172.25.99 equal www. Again, I repeat, access list 185 deny TCP, right? This network 212.77.7.0. Okay, because we want only the first 15, so 000.15 as the wildcard. Okay, to host, the keyword host, and then followed by 172.50 to 599 equal www. Okay. Then we want to permit the rest. So access list 185 permit TCP any to this host 172.50.25.99 equal www. Okay, that means the remaining lah, any except the 15, right? And then we want to allow. Do we want to allow? Oh yeah, we want to allow for to any, right? Not only for server. So access list 185 permit TCP any from here, any address apart from the first 15, any, and then to not host, not this one, any again, any, because there is no saying here that it's only for web server, right? So any equal www. Then finally, we identify where we want to put this ACE. So interface G001, IP access group 185 in. Okay.
Okay.
Okay. All right. Okay, so we move on to question 3. So question 3 with reference to figure 3.1, you're given a network topology here. All the hosts in C Unix and Bahat attached to switch 2. Switch 2 is here. Okay, so we are talking about PC1 and PC2. Should receive their DHCP version 4 IP address from the DHCP version 4 address server, but fail. Okay, it's failing to receive DHCP. And we see here in S3 here DHCP server. Okay, attached to S3 but attached to R2. Okay, as a network associate, propose and explain in detail how to configure the network device shown in figure 3.1 such that PC1 and 2 is able to receive their DHCP address from this DHCP version 4 server. We're required to use the information provided in figure 4.1. Figure 4.1, where's figure 4.1? Am I missing something here?
Maybe the typo.
Yeah, there's a typo.
Sorry?
It's
3.1
a
control
typo.
typo. Should be typo. Should be
Typo, not 4.1 but 3.1 bahkan.
Yeah.
To configure the network device shown in the figure 3.1. We also will provide in 4.1 in your I think this 4.1, not 3.1. Okay, so we're gonna use this info lah. All right, so where should we configure this?
R2.
R2. All right, so wait first. How to configure network device? It's weird that the question is especially propose and explain in detail how to configure. All right. Okay, so you have to explain what's happening and then propose how to configure it so that it works, right? So we know that DHCP version 4 uses DORA, which is discover, offer, request, and acknowledge. So the first thing is discover. So basically, if PC1 wants, you will have to send discover first, which will reach router 2, right? Okay, we know that the broadcast, it is actually a broadcast, right? Correct or not? The DORA, the discover is a broadcast, right?
Yeah.
Yeah. So broadcast, is it propagated by the router?
No.
No, right? So that means the router 2 here blocks that broadcast, which means the broadcast doesn't reach this server, this DHCP server, isn't it? So we know that for DHCP to work, the two PCs here need to send discover first. It's a broadcast because it doesn't know where is the DHCP server. So it sends a broadcast discover to R2. R2, because it's failed, right? So we assume that in this scenario, that's because the R2 will not forward any broadcast message because that's what the router doesn't do, right? So that means what should have been done in R2 in order for the router to able to work properly lah. Doesn't forward broadcast, but still allow for the PC to discover the DHCP. So it has to have a relay, DHCP version 4 relay service. So we assume that there is the DHCP version 4 relay service has not been configured on this G00 interface. Therefore, if it's not configured, R2 will simply block the discover or DHCP discover broadcast message. right? Because it's blocked, then the DHCP discover broadcast message cannot reach the DHCP version 4 server located in different network, which is 192.168.12.20/24. Sorry, 20 or 0. This is 0 lah, /24 and 12.0. Right here is 11.0/24. So different network. So block here cannot reach server, so the server cannot don't know how to reply. Right? So how to solve this? To solve this problem, you need to use a Cisco iOS helper address. You need to configure that so that the router R2 can acts as a relay agent to forward that DHCP discover broadcast message relayed to this DHCP version 4 server. Finally, what is the configuration? So at interface G00, right? IP type IP helper address with a dash in between now. IP helper dash address, okay, and provide this DHCP version 4 server address 192.168.12.200. Okay, so simply the configuration, that just not the explanation, you have to explain, yeah. So you have to explain it. That's the theory part. Basically the configuration, the last part of your answer will be the configuration. You have to have interface G00 and then type IP helper address, then the address of the DHCP version 4 server. Simply type like that. Okay.
Okay.
All right. Then it will work properly lah. That means the router will still not forward broadcast message, but if it detects discover broadcast message, it will help it along. It will forward to the address you specify there. Right? Okay. So we'll move on to question 3B. Okay, 3B. It says, assume that the DHCP, must see this one, DHCP version 4 server shown in figure 3.1 is unavailable to a technical reason. Configure router R2 to provide. All right. So we know that Cisco router can also provide DHCP version 4 service. What's the command to configure? Now the thing is, we need the IP address pool, right? So you can see here, right? Your pool should include this IP address lah. The 192.168.11.20, 192.168.11.21. So whatever it is that you provide, then you have to include that address, right? Okay, and then let me see, all right. Okay, so we know that the router should be static. The address for the router 192.168.11.9 should at router 2 should be static. You cannot use we cannot use DHCP for the router interface address. So we know that is static. So our pool, DHCP pool we configure on R2 must exclude this address 9. So to make it easy, we say that okay, our pool start from 20 onwards. Okay, and we exclude from 1 to 19. We exclude 1 to 19. 1 to 19 is used for static. 1 to 19 includes 9, right? So the DHCP can provide PC1 and 2 with 20 and 21 because we say we exclude 1 to 19 so that we still have a range of 1 to 19 for static, including the 9 here, right, for G00, right? So we start with identifying the router 2 config, type IP DHCP. Let me just type here. So IP DHCP excluded address. The excluded address, of course, the hint is that the interface G00 must be static, so we must exclude including that address. So it's 168. We can, so if you just put 1 to 9, it's also okay. When you say 10 to whatever is our pull for the SCP, also okay. So I'm just giving an example. So one the pool is to be excluded from the SCP pool is this. As I said, mentioned before, if you want to, instead of 1 to 19, 1 to 10 also can, because 9 is still belong to the excluded address. 9 because you know the 9 for the R2G00 must be static. So when we do that, then we put IP DHCP pool, we call it LAN. Do they give any name? No. So just put LAN 1. Right? IP DHCP pool LAN 1. And then we provide the network 192.168.11.0 and 255.255.0 subnet mask. Okay, and then default router. This is the default gateway lah. Default router, and G00 is our default gateway address. So 192.168.11.9. This will be provided to the PC asking for DHCP, right? And then for DNS server, do we have a DNS server here? We do. The IP address is given, so DNS server IP address is 192.168.12.99. Okay, we can see that at the bottom below the DHCP server, we have DNS server, right? You can see that, so that's DNS server address, right? So now we provide the pool, we provide the gateway, which is default router, and we provide the DNS server, right? So that completes our what lah? Our configuration for DHCP4 on the router 2. Okay. Any questions for that?
So no need the domain name, right?
No need. There's no domain name info here.
Oh, okay.
Yeah. If they do provide, then you can put in, but seems like none provided. So none. Okay, so let's move on to C. C is about the network address translation table. So let's recall what is that. Okay, so when you have a IP version 4 range of address, private address in your LAN, okay, and need to communicate on the internet, right? And you basically only have one global IP address. So you need a net table to translate between all the inside local private addresses against the global IP address, right? So again, based on the topology just now, relate to the topology, identify and explain the most suitable type of network address translation used by web server 1 and 2. And then you are required to propose a relevant address for both web servers by using table. This one you populate here. Right, let's see. Where's the web server 1? Web server 1 here, web server 2 here. So basically, we already have the inside local address, which is web server 1. Identified, yeah, web server 1 here inside local 192.168.33.1. Web server 2, second here, will be 192.168.33.2. Right? And then Okay, so we fill up the inside. Actually, we have to identify and explain the most suitable type, right? So what will be the most suitable type? Well, you see, this is web server, right? Web server. Web server, people need to be able to access all the time, isn't it? And the IP address inside your LAN also must be not changed lah, correct? Cannot be by DHCP or whatever. It must be static, and because it's a web server, any computer provide service, you must provide static IP address, and therefore you have to maintain the mapping. So the best the most suitable NAT to be used by web server 1 and 2 is the static NAT, right? Static NAT. Okay. So because these are two separate web server, you do not want to people to have um, two separate global IP address. Sorry, single global IP address. Because if you use the normal NAT, right? So that means one global IP address can go to two web server. Then usually people don't for web server people don't use IP address. People use domain name, and domain name usually is linked to a unique IP address. Okay. Yeah. So because you want to separate, it's different if these web servers are meant to be seen as one, like Google. Google, many web servers, backing up its Google search engine, but they want it to be seen as one. So that is a different scenario. Here we have two web servers that we want people to be able to see. We are not like Google that we are trying to combine two to be seen as one. We want these two to be separate. So if you want these two to be separate, means each of these web server must have its own global IP address. So static NAT allows you to assign one public IP address to one private IP address. So one global IP address or public IP address to web server 1 and another one, different one to web server 2. So that's why we choose static NAT, right? So this is commonly used for servers that need to be accessed by external devices or for devices that must be accessible by authorized personnel when offsite. Means you want them to be able to reach this web server individually, right? And what's happening here is one-to-one address mapping between local and global address, right? So if let's say you want to provide global address. That means here we already know 192 on inside local 192.168.331, 192.168.332. So that means the inside global two of them must be different, right? So what address inside global? Just look at the ISP provided. ISP provide for everyone here 211.151.100.529. So that means this mapping net will be on the edge router R0. Okay, so we cannot use 5. 5 is used for everyone else, right? So you can either give 4, 6, 7, right? 211.151.100.4, 211.151.100.3, or whatever, right? As long as not .5, because .5 is already used by others. So you can put beside here, right? 211.151.100.6, and the second one 211.151.100.7. That means the point is the two must be different from each other, and this one at the R0. That means you have to have three global IP address. No? Does that make sense to you guys?
Yeah.
Mhm.
All right. So can we use 7?
Can
Are you sure it's slash 29 or?
oh um,
The maximum is 6, right? Be careful, Oh, sorry. Yeah, slash 29, no? Slash 29, so you have a limited number of IP address can be used. I think .7 is broadcast already. So between .1 to .6, except .5. Okay? .0, of course, cannot. That one is subnet address. And then .7 is, if you look at slash 29, that means the .7 is the broadcast address. So you cannot use 7, you cannot use 0, you cannot use 5, because 5 already used here. So you can use 1, 2, 3, 4, and 6, whichever you choose. Any two of those. Is that okay?
okay.
Okay.
Okay, right. All right, so let's move on to the last question, question 4. Right, so this one, a lot of theory question. Will be good also if you got the theory question, but you have to write more because 9. So usually you can tell that if you got 9 marks, then you have to write more to get to hit the 9 marks. Not simply a lot of description, but I think um, you spread out your answers that it touches on. So if you like 9 here, you may make a comment on what they wanted, right? And then you might give examples. Giving examples also is a good way to what lah, right? In this case, let's look at the comment. Without wide area network, LANs will be a series of isolated networks. Yes, that's correct. Because without wide area network, LAN will be isolated. The only solution is to use private wide area network infrastructures to interconnect the LANs. Try to figure out that sentence. Is that correct? The first part, I think, is correct. Second part?
No. Very
Which part is incorrect? Which part doesn't sound right?
the use to use one private
Private, yeah,
private.
the keyword private,
Yeah.
Why must be private? As far as we know, private doesn't work in the biggest wide area network because if it's private, it goes beyond border? Because wide area network go beyond border of a country, right? So private in terms of countries, nationalities cannot. In terms of provider like Google, Microsoft, because they're so big and so they're international, they might try, okay, but I don't think
Does the China one private?
not necessarily, because they do allow certain services that that they support, they like. Not only outside of their country, but inside the country can
This
reach out.
thing,
You
still
can
not,
reach
not
out.
so,
Yeah,
not so, not so
yeah.
visible.
There's still some open parts of their network, not completely private. I believe the completely private will be Korea, but that's just one small isolated country, lah. So in general, we don't say that Korea situation is general. China is not really private, lah. Although they try to censor, but they still allow for certain traffic that they support, the Chinese government support, right? So that's still okay lah, But Korea, I believe, is total what lah. But that is not representative of the entire global network. Korea network is too small to be considered. That's the we call that outlier, not the norm, right? So this one is something that is a problem, right? So this is not correct. So that means in your answer, you will comment on this, right? And when you comment on it, you give your thoughts, right? You give your thoughts why you think this is correct, right? There are sample answer here, but I believe the marker will depend on your personal answer. As long as your answer is correct in terms of the logic, lah, right? Without wide area networks, lens will be. I mean, this is correct. So why do you think that is correct, right? Without wide area network, is it true that lens will be isolated to each other? Of course, they cannot connect, right? So you explain that, and then you comment on the second part. You say it's wrong. Why do you think it's wrong? Then you identify the part that you think is wrong, and then you give the correct, okay, the correct statement. Instead of private, you say, then you give your reason why you think private is not private, actually you think it's public, right? Okay, and then let's look at the third statement. In addition, the internet-based broadband connectivity is limited to wide options like, is it correct? Which, okay. In addition, the internet-based broadband connectivity is limited to wide option like DSL and fiber optic. First of all, is it true?
No.
No.
No, right? We can have satellite. We can have wireless broadband connectivity, like the mobile 4G, 5G, all this, right? And there are several technologies, lah. Okay, so not only fiber or DSL can provide broadband. So again, you comment on that why you think is wrong, and then you explain what the actual correct part. It says which cannot connect LANs together. Cannot, eh? Can, right? Can connect LANs together.
Can.
Yeah. So this one, the private one, infrastructure is wrong because it says only solution. You can use private, but it's not the only solution. So it's incorrect in that sense, especially for wide area network. In fact, there are many, not only countries lah, even companies also, they want to protect their they want private wide area network infrastructure, but not in the infrastructure that we think. Infrastructure for companies, wide area network, they use some sort of VPN, right? Virtual private network. They can create their own private wide area network using software solution like there are two. One is circuit-based virtual private private network, virtual-based private network controlled by ISP, right? So just to make sure all the infrastructure you use and you pay for very much, it's only used by you. But you want a cheaper option, then you will use public infrastructure, the internet. Then you have to use VPN, isn't it? Yeah. So like say, TAUC Sabah, TAUC main campus, they don't want to use internet VPN to connect, so they can actually pay more to say that, okay, this particular connection between Sabah and main campus must be using the line that is only for us. No other traffic can mix in. They can, because telecom or TMNet can provide that because they own the infrastructure. Okay, but you have to pay more lah. You have to pay more expensive, right? So sometimes when people tell you, oh, so expensive, it's not only just because of the speed. For the speed, you can see unify, you pay less, you get more speed. But it's because you are the sole user. At that speed, for that line, you are the sole user. So sometimes we call it this line, right? Okay. So that is that when you connect geographically disconnected, I'm sorry, geographically located places, okay, and you're using that kind of technology, the infrastructures belong to you because the ISP, you pay the ISP for it, then that is private wide area network. All right. So you can, but that's not the only way, because if that's the only option, a lot of people cannot afford, right? A lot of companies cannot afford. Not all companies can afford this kind of payment. Monthly is very expensive. So some companies, smaller companies, they will go for um, virtual private network, VPN, VPN type of services. All right. So from you can see three statement, three marks, Omira, 3 marks, right? 9 marks, three sentences. Yeah, 3 marks there. 3 marks, 3 marks, 9 marks. Huh? Right. So let's go to B. It says a junior network engineer does not understand the following statement. When congestion occurs, network devices will drop packets. This includes time-sensitive video and audio packets. Right. So what does it mean? So you have to explain to this junior network engineer, right? And propose a solution so that this one, if there's congestion, at least time-sensitive video and audio packets will be optimized lah, right? So what do you think this question is about?
Quality of service.
Yeah, quality of service, or otherwise known as QoS. I think the hint there is about the part where it talks about video and audio packets. Yeah. So straight away, you know already, video and audio packets is these two types of traffic is the ones that actually the QoS is introduced. Okay, because of these two. This time sensitive, because without the QoS, you won't be able to hear me like right now in our video conferencing like this, yeah, right? Now it's audio conferencing, but you can see the screen there, right? So video conferencing. Without QoS, this will not be achievable. So that means your answer here is geared towards QoS. Okay, QoS. Right. So without any, so I'm just going to read what I have here. Without any QoS mechanism in place, packets are processed in the order in which they are received. Hence, when congestion occurs, network device will drop packets. Voice and video traffic place a greater demand on the network and are two of the main reasons for the availability of QoS. Voice packets do not consume a lot of resource because they are not very large and they are fairly steady. Voice traffic requires at least 30 kilobits. This one, I'm not sure you can write in this detail unless you memorize. I think it's enough for you to say that. No need to say, but if you can memorize, then okay lah. You can say the requirements, the traffic requirement is 30 kilobits per second of bandwidth, no more than 1% packet loss. So the thing is, voice packets are not so vulnerable as video traffic. Video traffic is more demanding. It's bursty, greedy, consumes a lot more resource. You see, very steady. You see the encoding of our audio, right, is pretty steady because you have to look at compression. Now, video compression, okay, depends on the scene. The scene meaning what is shown on the video image. if it's very messy, a lot of explosion, all this going on the screen, that means the compression ratio is going to be bad. That means it cannot compress as much. If it's a horror movie, a lot of dark scene, then the compression ratio will be very good. Then more can be sent. You guys understand me? This concept. Yeah.
Yeah.
Compression bar, right? Okay. The more you compress, the better. The more you can send, right? But the compression ratio, it depends on the scene of the film, the video. The more complex the complex scene, compression will be bad. The less, like cartoons or whatever, that one is easier to compress. Compression ratio will go up, and means you can send more video. All right. Now, for audio, doesn't matter. The audio is always the same. It's not as demanding as video in that sense. The compression is maintained, right? Maintained. You think about Spotify, and even with Spotify, Hi-Fi or Tidal, all this streaming, right? They're able to they actually very consistent with their. It's not as demanding as YouTube, right? YouTube, you need uh, very good compression, and also the power to compress those video before sending it away, right? So that's what we talk about, the demanding video traffic, and it's bursty and greedy, consume a lot more resource. It needs at least minimum 384 kilobits per second in bandwidth, with no more than 0.1 to 1% loss. So the thing is, audio, when that means packet loss means you will miss certain thing. I'm saying that, right? But it's not too obvious compared to video. If video you miss frames, then suddenly you lost context already when you're watching the video. So the solution to improve, okay, to improve voice and video traffic in terms of congestion, is to implement QoS, quality of service policy, right? This policy is activated when congestion is detected on the link, right? So in terms of congestion management tool, they use queuing. You can buffer, you can prioritize, and reorder packets. This is the QoS policy. You can buffer packets, you can prioritize back packets, and then if required, you can reorder them also before you transmit them to the destination. So there are a few suitable queuing algorithms. We have weighted fair queuing, class-based weighted fair queuing. I remember this talking to you guys about this. Low latency queuing, LLQ. The first in first out is not acceptable. This is the one without QoS. Since we are talking about QoS, so your answer cannot include FIFO. FIFO is without QoS. All right. So the rest, okay. WFQ, weighted fair queuing, class-based weighted fair queuing, low latency queuing, right? So the three models for implementing QoS are best effort model, integrated services, or differentiated services, right? All right. So I think that's it, right? You can I think you can answer in that manner, okay, and to get 8 marks lah, right? And then the last part, discuss confidentiality and integrity of IPsec. Right. So IPsec is IP security. I think this one is not mistaken. This is the IP version 6 security protocol. This one. Anyway, you need to talk about confidentiality, integrity. So you have 8 marks, so 4 marks for this confidentiality, and 4 marks for integrity, right? Okay, so confidentiality means encryption, right? Encryption. So confidentiality means you don't want people, you want to keep the info during transfer the data confidential. So the only way to do that is to encrypt it. So the degree of the confidentiality depends on the which encryption algorithm you use, and as a parameter, the length of the key that you use in your encryption algorithm. The longer the length, the more secure it is, the harder for attacker to break the encryption, right? Because the number of possibility that the attacker needs to consider to try to hack what is the key of your encryption function is depend on the length of the key, right? If you provide a short key, then it's easier to break. Longer key, harder. So a function of 2 to power of the length of the key. So you can see the what lah, the what I mean lah, the possible combination, right? Okay. Then the encryption algorithm highlight in the figure are all symmetric key. So we have a symmetrical key crypto system. In fact, they are asymmetric. Asymmetric means you cannot, it's a one-way encryption, which means to say you you encrypt the message, but later on only you have the private key. So if you give the correct private key, the hash of the encryption will be the same. If you don't, if you're not, then it will not be the same. So there's no way to reverse back. That means the people will not know what is actually the password, right? So that's why every time it's always going to overwrite your password if you forget your password. That is asymmetric. But symmetric means you can encrypt using the key and decrypt, get back the original value using the key, using the decryption function. So the encryption algorithm that we consider here in the confidentiality is the symmetric key crypto systems. Okay, so we have DES. DES uses 56-bit key. We have 3 DES, means it's using 3 separate independent 56-bit encryption keys per 64-bit block. And then we have AES, right, that can provide 3 different key lengths. You can have 128 bits, 192 bits, 256 bits. Of course, the 256 bits key length is the most secure for AES. And then we have the SEAL, SEAL, stream cipher. That means it can encrypt data continuously rather than encrypting blocks of data. SEAL uses 160-bit key. So confidentiality is all about encryption. So here, any 4 points that you make, right, you can get one mark. Well, 4 points, one mark each. You get 4 marks for confidentiality. Then for integrity of the data means if I transfer my data, I don't want it to change during transit. When it arrives at destination, it should be the same data that I sent out. So that means my data should not have changed in transit or while being transferred, right? So there must be a way to prove that there's no change. So data integrity is maintained. So one such method is to use hash message authentication code. It is a data integrity algorithm. It guarantees the integrity of the message using a hash value. It's always a hash value. You have a hash function, whatever the name of the hash function, right? You pass your data through the hash function, it generates a hash value. Okay? If you have the hash value and then the destination, you give the hash value to that person. The person, when they receive your message, they pass it through the hash function again. If they get the same hash value, then they know the data is intact. There's no tampering with it. If there's a change in the data, it will produce one. If you pass it through the hash function, it will produce different hash value. Then the two value doesn't match, then you know something is wrong, right? So we can use hash message authentication code as the hash function. We can use message digest 5 ND5. This one use 128-bit secret key, or we can use secure hash algorithm or SHA that uses 160-bit secret key, right? So integrity basically allows you to make sure that the data is not tampered with or changed during transit. All right. So again, any 4 points gets you 1 point each, or 4 times 1 point to get 4 marks. So add them together, confidentially 4 marks, integrity 4 marks, you get 8 marks. All right.
Is it usually 1.1 mark or 1.2 mark? It's like
Well,
one.
you can see that to be safe, 1.1 mark, right? If you just like 4 marks there, right? Because sometimes they do give like 2 points, 2 marks each. But of course, for 2 points, you have to describe more. That means there's more explanation to get the two marks. That's how they weight the marking. The way I see it, they provide the mark like that. So if it's a short info, usually it's 1 mark. So four short points, or four short info, will give you 4 marks. If you explain, then it's longer a bit, then it's 1 point is 2 marks if you provide longer explanation, right? And if it's 3 marks, sometimes like that, right? Then usually it's you identify, you explain, and then if it's 4 marks, identify, explain, and provide example. Usually it's this way lah. But you have to look at the question lah. If the question asks for example, then definitely provide example. If it doesn't, then not necessarily you need to provide example. But if you want to provide, just to be safe, you can provide. Only if it makes sense lah from the question. Any other questions?
No. I think I got dinner. Is it?
Yeah, okay, already, Kelvin. How about you, Noel?
Okay.
Okay, all right. So if I just want to wish you guys do well tomorrow. Okay, tonight don't stay up too late. You need your rest also. Wake up early tomorrow so that you'll be early at the campus, right? So I will be at my office. I will, whenever my paper is being invigilated. I cannot be invigilating lah. So I won't be seeing you guys. I will be in the office lah. Anyway, should be okay lah. Huh?
When I write the code, so I don't need to write the config. I double check that.
Oh, this one, the router config. Yeah, no need to write that. It's okay.
Even if there's another layer, like the some.
Yeah, even if another layer.
Okay.
But if you're concerned, because for me, that one is not part of the answer for me, right? But more importantly for me, it will be to identify where your commands you want to put in, which device.
Oh, okay. As long as you know where I can.
Yeah, where, which router, which switch, that configuration.
Okay.
Yeah, because that's not part of the command. It's actually provided by the system. But if you write it, no problem. You don't write it, no problem as well. Important, identify the device where the command is. Okay?
Okay. Thank you, sir. I go eat dinner.
Okay, go to dinner. Thank you. Bye-bye.
Okay. Thank you, sir.
Noel, bye.